In this video, we're going to complete the KutaSoftware Infinite PreAlgebra free worksheet proportion word problems. So our instructions are to answer each question and round your answer to the nearest whole number. So in number 1, let's jump on in. It says, if you can buy 1 can of pineapple chunks for $2, then how many can you buy with $10? So let's set this up proportionally. So if we can buy 1 can of pineapple chunks for $2, that will be 1 can for $2. So we'll put 1 can in the numerator and $2 in the denominator. That's going to be equal to how many can we buy with $10? So because this is asking us how many, let's make that a variable. Let's make this variable x. So x cans, that's the number of cans we can get with $10. So we'll put $10 in that denominator. Now we'll just solve this like any other proportion. And in all honesty, it might be easier to take some of the labels off to see the proportion a little more clearly. So I'm just going to write 1 can over $2 as 1 over 2, and x cans over $10 as x over 10. Now we're just going to solve this proportion how we normally would. So if you haven't done the proportions worksheet first, go ahead and do that now, or look it over as a quick refresher. But in order to solve, we can either cross multiply, we can find some relationship, etc. So 1/2 equals x over 10. If I were to cross multiply, 1 times 10 is going to be equal to 2 times x. So 10 equals 2x. Now all I have to do is divide by 2 to get my solution of 5. Because the 2 will cancel out and I'll be left with x, and 10 divided by 2 is 5. So 5 is my solution in number 1. And here's another way to think about it. In order to go from 2 to 10, we had to multiply by 5. So we're going to do that same to the numerator to solve for x. We'll take 1 and multiply that by 5. 1 times 5 gives us 5. And real quickly, just to give you another option, we could also think about this as 1 times what gives us 2. That's 1 times 2 gives us 2. Or really, we'll think about it this way. 2 divided by 2 gives us 1. So what do we have to divide by 2? We have to divide 10 by 2 to give us x. 10 divided by 2 is 5. So that's just a couple different ways to think about those proportions. Let's go ahead and move on to number 2. In number 2, we have 1 jar of crushed ginger that costs $2. So we're going to have 1 jar, so the number 1, over $2. So 1 over 2. How many jars can you buy for $4? So we want to know the number of jars, and that takes place in our numerator. Since we put 1 jar in our numerator over here, our jars is going to remain in our numerator, but we don't know how many there are. So let's do another variable. Let's do this variable as j this time for jars. And that $4 will go in the denominator. So how many jars can we get if we spend $4? And think about it. To go from 2 to 4, how do we get there? And when I say that, I mean either multiplying or dividing. Not adding or subtracting, only multiplying or dividing. To go from 2 to 4, we need to multiply by 2. So in order to get j, we're also going to multiply by 2, and we're going to multiply 1 by 2. So 1 times 2 will give us 2. So 2 jars is the amount of jars we can get for $4. And if you want to see that cross multiplication, 1 times 4 is 4, and that's going to be equal to 2 times j. Divide both sides by 2. The 2 will cancel out. 4 divided by 2 is indeed 2. So there's not just one way to think about these problems. Feel free to use whatever is easier for you. And again, I recommend reviewing that proportions worksheet if you're confused on how I'm solving these. Let's move on to number 3. In number 3, we have one cantaloupe that costs $2. So again, one item costs $2. So 1 over 2. How many cantaloupes can we buy for $6? I'm going to leave my money in my denominator. So because I have $2 in my denominator, I'm going to have $6 in my other denominator. I have one cantaloupe in my numerator, and I'm trying to figure out the amount of cantaloupes I can buy. So I'll call this variable C this time. So let's think about number 3 slightly different than we did number 2. 1/2 is a fraction. How can we make 1/2 equivalent to something over 6? Well, we know that to go from 1 to 2, we multiply by 2. So we're going to have to do the same from the numerator to get to the denominator. Or we can think of it as the reverse. Going from 6 to C, as opposed to multiplying by 2, we need to divide by 2. Because to go from 2 to 1, we divide it by 2. So C over 6, what equals 1/2? That's going to be when C is equal to 3. 6 divided by 2 gives us 3. 3 times 2 gives us 6. Or if you want to think about it, 2 times 3 gives us 6. So 1 times 3 will give us 3. And then cross multiplying, we'll get that 6 is equal to 2C, which when you solve for C, you'll get 6 divided by 2, which is indeed 3. Again, just a couple of different ways to think about this. Let's continue on to number 4. In number 4, it says one package of blueberries costs $3. So I'm going to leave the one package at the top, and I'm going to put my money in my denominator. So 3 is going to go into my denominator. It asks, how many packages of blueberries can we buy for $9? So we have an unknown number of packages. I'm going to call that variable P for packages, and I'm going to put the amount of money that we have in our denominator, which is 9. Now this is nice because 3 times what gives us 9? That's 3 times 3. So we're going to do the same to the numerator. 1 times 3 gives us P, so P is equal to 3. 1/3 is equivalent to 3/9. It says Shauna reduced the size of a rectangle to a height of 2 inches. What is the new width if it was originally 24 inches wide and 12 inches tall? So this one's worded slightly differently, but we're going to relate our known variables together. So it was originally 24 inches in width and 12 inches as its height. So if I put 24 inches for the width, so I'm going to say 24 inches wide over 12 inches tall. These are the original dimensions of the rectangle. So if Shauna reduced the height so that it's only 2 inches tall now, remember our amount of height, how tall the rectangle is in our denominator. So I'm going to put that 2 inches in my denominator. We're trying to figure out the new width. So if the 2 inches tall is the new height, the new width, we'll call this W. So just writing this as numbers, we'll have 24 over 12 equal to W over 2. So if we think about it, how do we go from 12 to 2? Well, we simply divide by 6. And you know what? We're going to do that same thing to 24 to go from 24 to W. Divide by 6. 24 divided by 6 gives us 4. So the width of the new rectangle is 4 inches. And that's as long as we keep the dimensions proportional. Now, when reading this problem, you might have set up your proportions slightly differently, which is completely fine. Let's say that as you read this problem, you were writing down your given information, you saw that she reduced the height to 2 inches, so you know you have a 2-inch height, so I'm going to say 2 inches tall, and you want to know the new width, so that's your question mark. So again, that's your W, and that's equal to, remember, we have to keep the same types of numerators and denominators. So because I now have my height, or how tall the rectangle is, I need to put 12 inches tall in my numerator and that original 24 inches wide in my denominator. So right now you can see that my proportion is going to be 2 over W equals 12 over 24. Well, I didn't really change the problem up at all. We're still going to get the same value for W, which is the neat thing about proportions. It doesn't matter how you set them up, as long as your numerator is the same type and your denominators are the same type. Or you could set it up so that the same types of units are all within the same fraction, but you just have to make sure that those numbers that are linked together, for example, the 24 and the 12, since they're part of the same figure, would have to remain in the same places. But let's continue on with how we're doing it. So 2 times what gives us 12? That would be 2 times 6. Or, because we don't know what W is, we can go the reverse. 12 divided by 6 gives us 2, so 24 divided by 6 gives us 4. And again, that's 4 inches. So either way you set it up, you'll get the same result. Let's move on to number 6. In number 6, it says, Ming was planning a trip to Western Samoa. Before going, she did some research and learned that the exchange rate is 6 tala for $2. How many tala would she get if she exchanged $6? So our given information is, we know that we can get 6 tala for $2. So that's a 6 to 2 ratio. 6 over $2. Now I need to put my dollars in the same place, so this $6 is going to go in this denominator. And I'm going to solve for some variable, and I'll make that variable t for the tala. 2 times what gives us 6? That's going to be 2 times 3. So now we just need to do 6 times 3 to get t. 6 times 3 gives us 18. So she's going to need 18 tala. Now, as I mentioned previously, there's more than one way to set up a proportion. The other way we can do it is by keeping the tala in the same fraction and the dollars within the same fraction. We just have to make sure that those that are linked together remain in the same place. So because it's 6 tala for $2, I can write 6 tala and $2. And then how many tala would she get if she exchanged $6? So let me make sure I write, this is going to be 6 tala, this is $2. I'm going to write my t for tala because that's what I'm solving for, and the linked dollar amount to that is $6. And you can see this is going to give me the same exact answer. 6 divided by 3 gives me 2, so 2 times 3 gives me 6. That means I need to do 6 times 3, which will give me, again, 18 tala. So that's another way to look at setting up these proportions. Just make sure you're linking those numbers together. So the numerators have to be similar and the denominators have to be similar. So for example, in our first setup, the 6 and the t were both tala, and you could get 6 for 2, and then how many for 6, whereas in my second proportion I set up, the numerator was how many tala you could get for $2, and that was that same relationship in the denominator, except it was how many for 6. I had talas over here and dollars over here. So you can see those numbers do indeed link up with the given information. So just another way to think about it. Let's move on to number 7. In number 7, it says, Jasmine bought 32 kiwi fruit for $16. How many kiwi can Lisa buy if she has $4? So we know we can do 32 kiwi for $16. How many kiwi can you get? So since kiwi was in our numerator, that's what I'm questioning, so I'm going to call that K. How many kiwi can we get if you have $4? Let's find the relationship between 16 and 4. Well, 16 divided by 4 gives us 4, so all we have to do is divide 32 by 4, and that's going to give us 8 kiwis. So 8 is the solution in number 7. In number 8, it says if you can buy 4 bulbs of elephant garlic for $8, so that's 4 bulbs for $8, how many can you buy for $32? So how many bulbs B can I get for $32? Finding that relationship, 8 times what gives us 32? That's 8 times 4. So 4 times 4 will give us the amount of bulbs we can buy for $32, which is going to be 16 bulbs, because 4 times 4 is 16. For number 9, it says that 1 bunch of seedless black grapes costs $2. So 1 bunch costs us $2. How many bunches? So I'm going to say B bunches, where B is our variable. How many bunches can we buy for $20? So the relationship between $2 and $20 is we need to multiply by how much? 10. 2 times 10 gives us 20. So we're going to multiply 1 by 10 to give us B, that amount of bunches. And 1 times 10 is 10. So 10 bunches is what we can buy for $20. In number 10, it says the money used in Jordan is called the dinar. The exchange rate is $3 to 2 dinars. Find how many dollars you would receive if you exchanged 22 dinars. So $3 to 2 dinars is our ratio. So I'm going to have $3 to 2. Then I'm going to see how many dollars I can get. So I'm just going to call this X amount of dollars if I exchanged 22 dinar. Well, 2 times what gets us to 22? That's 2 times 11. So all I have to do is take that $3 and multiply that by 11 as well. 3 times 11 is 33, so that's $33. Now on to the second page. Gabriella bought 3 cantaloupes for $7. So 3 cantaloupes for a rate of $7. How many cantaloupes can Shayna buy if she has $21? So I'm going to say C cantaloupes. So C is our variable. How many cantaloupes can Shayna get if she has $21? How do you go from 7 to 21? That's multiplying by 3. So all we have to do is multiply my numerator by 3 as well to get to C. 3 times 3 is 9. So Shayna can buy 9 cantaloupes if she has $21. So Jenny was planning a trip to the United Arab Emirates. Before going, she did some research and learned that the exchange rate is 4 dirhams for every $1. So that's a 4 to 1 exchange rate. How many dirhams would she get if she exchanged $5? So my variable here is going to be D, and we're curious how many she would get if she exchanged $5. 1 times 5 gives us 5, so we just need to do 4 times 5 to give us the amount of dirhams. And I apologize if I'm pronouncing any of these currencies incorrectly. 4 times 5 gives us 20. So that's a total of 20 she would get if she had $5. For number 13, it says Castell bought 4 bunches of fennel for $9. So that's 4 bunches of fennel for $9. How many bunches of fennel can Mofar buy if he has $18? So how many bunches? So I'm going to say B bunches, or actually let's use the variable F for fennel. So F bunches for $18. Well, you can see that 9 times 2 gives us to 18. So we just need to take those 4 bunches and multiply that by 2 to get a total of 8 bunches. So he can buy 8 bunches of fennel for $18. In number 14, it says if you can buy 1 fruit basket for $30, then how many can you buy with $60? So if you can buy one fruit basket for $30, how many can you buy? So how many baskets? I'll call this F baskets for fruit baskets, where F is going to be our variable. So if one basket costs $30, F baskets will cost $60. So what exactly is F? Well, to go from $30 to $60, I need to multiply by 2. So to go from one basket to F baskets, I'm also going to multiply by 2. 1 times 2 gives me 2. So you can get 2 baskets of fruit for $60. And just a quick reminder about the cross multiplication method, we would do 1 times 60, which would give us 60, and that would be equal to 30 times F. Then all we would have to do is divide by 30 to get F isolated, or all by itself, and 60 divided by 30 is indeed 2. Now, why I reiterated the cross multiplication method is for these next couple of problems. We're going to be answering each question, and we're going to round to the nearest tenth and round dollar amounts to the nearest cent. So that would be the nearest hundredth. So Ansanji took a trip to Mexico. Upon leaving, he decided to convert all his pesos back into dollars. How many dollars did he receive if he exchanged 42.7 pesos at a rate of $5.30 for 11.1 pesos? So let's start with what we definitely know. We know that the rate is $5.30 for 11.1 pesos. So I'm going to write this as $5.30 per 11.1 pesos, or for 11.1 pesos. And that's going to be equivalent to, well, we need to see how many dollars that he received. So our dollars, I'm just going to put this amount as X, which is what we're trying to solve for, if he exchanged 42.7 pesos. Now, right off the top of your head, it's difficult to see the relationship between 11.1 pesos to get to 42.7. It's not nice like the ones above, numbers 1 through 14, where it was some simple whole number. So this method, we're going to do cross multiplying. So we're going to do $5.30 times 42.7 pesos. So if we do $5.30, and feel free to pull out a calculator for this, and you multiply 5.30 by 42.7, you're going to wind up with 226.31. And that's going to be equal to X times 11.1 pesos, or 11.1 pesos times X. So I'll have 11.1 times X. So in order to isolate this X, I need to get rid of this 11.1, so I'll divide both sides by 11.1. And in doing so, when I take that 226.31 and divide it by 11.1, I get 20.388, which, if I'm trying to find the dollars, they told us to round to the nearest cent, so I'm going to round to 20.39. So this is going to be $20.39. And again, that's because 226.31 divided by 11.1 gives me $20.39 after rounding. Also, if you wanted to see this as an equality, you could have also set your proportion up as 530 equals 11.1. We're dividing by some dollar amount X, but that's the same rate as dividing by 42.7. When doing this method, we'll still cross multiply, except this time we're going to multiply 5.3 to 42.7. It's the same as here, and then we'll divide by that 11.1 because 11.1 times X is that other cross multiplication. So you can see that we have the same proportion, it's just set up slightly different. But similar things will still be multiplied together. So there's not necessarily one correct way to set it up, However, there are definitely incorrect ways, so be careful making sure those numbers are related or linked together like we talked about previously. In number 16, it says that the currency in Argentina is a peso. The exchange rate is approximately $3 for 1 peso. So I'm going to write that as a fraction. So I'm going to say, okay, it's $3 per 1 peso. At this rate, how many pesos would you get if you exchanged $121.10? So if I exchanged $121.10, how many pesos would I get? I'm going to call that variable P. So P pesos, where that P is the variable I'm looking for. And again, I'm going to do this by cross multiplying. So 3 times P is going to give me 1 times 121.10, which is 121.10. In order to solve for P, because that's how many pesos I need to find, I'm going to divide both sides by 3. When I do that, 121.1 divided by 3 is going to give me 40.36 repeating. But remember, we're going to round to the nearest tenth because we're not dealing with dollars in this case. So 40.36 rounds to 40.4. So that's 40.4 pesos. In number 17, Mary reduced the size of a painting to a width of 3.3 inches. So we have a width of 3.3 inches. What is the new height? So that's the new width. What is the new height if it was originally 32.5 inches tall and 42.9 inches wide? So if we have a new width of 3.3 inches, we want to figure out the new height. So I'm going to write H for height. So because I have my width in my numerator, I've got to make sure I'm writing it in my numerator for the original painting as well. So that's going to be 42.9 inches for the width over a height of 32.5 inches. So you can see both my heights are in my denominator. Now what I got to do is cross multiply. So 3.3 times 32.5 is going to be equivalent to H times 42.9. So doing this out on my calculator, when I do 3.3 times 32.5, I get 107.25. And that's going to be equal to H times 42.9. But in order to isolate the H, I need to divide by 42.9. So now I know that my height is going to be 107.25 divided by 42.9, which gives me 2.5 exactly. So 2.5 inches is my new height of the painting after it was reduced. So again, that's 2.5 inches for number 17. Let's move on to the last question, number 18. If you've been finding this video helpful, don't forget to click that thumbs up button. But now let's finish this out. It says that Molly bought 2 heads of cabbage for $1.80. So that's 2 heads of cabbage for $1.80. How many heads of cabbage can Willie buy if he has $28.80? So how many heads of cabbage, we'll call this variable H, can he buy if he has $28.80? Here we go with a little bit more cross multiplication. So I'm going to do 2 times 28.80. That's going to give me 57.6. And that's equal to $1.80 times H. So 180 times H. Now, if I divide by $1.80 or 1.8, that'll leave me with H isolated, so I'll know how many heads of cabbage Willie can get for $28.80. So take that 57.6 and divide it by 1.80 to get exactly 32 heads of cabbage. So 32 is our final solution on this worksheet. If you have any questions, please feel free to leave them in the comments below. If you need the link to access this free KutaSoftware website worksheet, I'll also leave that in the description below as well. But as always, don't forget to like, subscribe, and share. Thanks again. See you next video.